guys, welcome to our peer teaching video. I am your presenter for today. At your service, Jenny Olibunao. Now, we will explore the concept which the great minds in science had debated upon. Light. Is it a particle, a wave, or what? Let's get it on and explore the answer for the question, what is light? What is light? Maybe if you were the one that I asked, you probably said that light is something that makes vision possible, or light can be perceived by the human eye, or you probably told me that light is brightness. But today, light is defined as an electromagnetic radiation that can be detected by our eyes. Before the present ideas, scientists debated upon the true nature of light. Let us start. In 1637, Descartes set forward the corpuscular theory of light, stating that light is made up of small discrete particles called corpuscles, and it is pioneered by Isaac Newton in 1672. But this theory cannot explain the refraction, diffraction, and interference. That is the part where Huygens' principle came into the picture, stating that light is a wave, and are able to explain the three properties of light in 1690. But the dispute broke out in full force in 1711 when the Royal Society proclaimed in a study that it was Newton who was true. Royal Society is the world's oldest independent scientific academy dedicated to promoting excellence in science. Another person in 1801 proved that light is a wave, and this is through his double slit experiment, and that is Thomas Young. But in 1905, Albert Einstein postulated the idea of photon, a kind of light particle. And later on in 1924, Louis de Broglie indicated that light can be regarded as both waves and particles. In the end, light has a dual nature, a particle and a wave. But we're not yet done. Now, let us dig deeper to our next discussion. Huygens' principle and Young's double-slit experiment. Huygens' principle states that in every point on a wavefront is a source of wavelets that spread out in the forward direction at the same speed as the wave itself. It is by Christian Huygens, a Dutch scientist who developed a useful technique for determining how and where waves propagate. You can try this at home, where you will drop a water on a basin and you will see the generated wavelets. You can see that it is a continuous wavelets generated by different wave source point on every wavefront. It is the same speed as the wave itself. Now imagine that we have that wavefront. Now we will have a barrier. The wavefronts and wavelets will only able to enter that one point. We say that in every wavefront there is a wave point source. That's why even if that little wavefront will pass through, another wavelets will be generated in a circular motion. Diffraction. Diffraction is the ability of a wave to spread out and bend past a sharp edge or slit. That explains the sea, that once you create a disturbance in the water, there is a generated wavefront, and if you will create You will see de Young's double slit experiment. When monochromatic light passing through two narrow slits illuminates a distant screen, a characteristic of bright and dark fringes is observed. It is by Thomas Young, an English physician and physicist who established the principle of interference of light and thus resurrected the wave theory of light by Huygens. It is the image that Thomas Young saw. We have the bright and dark fringes of interference. Now, let us try this at home. You can get a box and let us seal it. Our goal is not enabling light to pass through in any holes of that box. Now let us draw a two narrow slit and an opening for us to see. Make sure that no spaces that the light will pass through except for the opening. Now you can see that there are bright and dark fringes in the video. It is explained by this animation. There are two slits. It generated a wave front, but it coincides. Let us see this illustration wherein there are two narrow slit openings. Wavelets will be formed on the two narrow slits, but you can see that there is this wave front that coincides. And it is affected by the another. You can see the lines wherein the waves coincide. That is called constructive interference. We also have that parts in the wave wherein it doesn't coincide, and that is the destructive interference. This is the animation. You can see that there are missing parts in the wavelets. That is caused by the destructive interference. You can do it at the lake. Thank you for listening. Prepared by Jenny Olibunao, PSED Science 3A.